As you can see, it doesn't have like a proper title, so we're going to put one on it. This is lesson 1-4. Perimeter and area in the coordinate plane. Perimeter and area in the coordinate plane. This lesson is actually going to start out with some vocabulary. Some of the vocabulary you've probably seen before, but maybe just you need a refresh. Some of it might be new. That's cool too. It's pretty simple, straightforward. Good. Need a pencil or anything? Okay. Yeah. So perimeter and area in the coordinate plane, but before we go to calculating all that, we're just going to start with some vocabulary. Starting out with the word polygon. I know you've heard that word before. You might not be able to like spit out a definition. There's like this long definition right here if you feel like reading it, but I am the queen of like shortening things and making them as simple as I can. So a polygon, by definition, by Miss Silva's shorthanded definition, closed figure with straight sides. So you've seen a lot of polygons. You've been working on polygons since probably preschool. Polygons are like a square. It has straight sides and it's closed, like all the sides connect to make a closed figure. Maybe a triangle, maybe a pentagon, 5 straight sides, they all connect. That would be a polygon. Something that is not a polygon. Something that is not a polygon would be like a circle because it doesn't have straight sides, or maybe an ellipse or an oval. Maybe something has 3 sides but it doesn't like close, it doesn't connect. Or like if you have 2 straight sides and then like a curved side, that would not be a polygon as well. So it needs straight sides and it needs to close. I'm gonna zoom in even further. I feel like we can get even more. Okay. Then to name a polygon, there is a specific way. So to name this polygon, we have to go in order, like we're connecting the dots with the letters. So we would name it by the corners. So this would be polygon A, B, C, D, E. When we name the dots, they have to go in order. It doesn't matter whether we start with A or with C, as long as you're naming them in order. So we could say this is polygon C, D, E, A, B. You could also go the other way around and say it's E, D, C, B, A, but you have to go in order. So this is polygon, we'll just go A, B, C order. A, B, C, D, E, and that's how you name the polygon. Also, the number of corners or vertices is the same as the number of sides. So if you see this with 5 corners, it's a 5-sided shape. Okay, next. Okay, next, this is probably new. We're going to talk about regular polygon versus irregular polygon. So you will see this word regular polygon a lot. And it seems almost like polygon. Let's spell polygon right. It seems almost like non-inconspicuous, like unimportant, but the word regular before polygon is actually really important. So regular polygon versus irregular polygon. Okay, a regular polygon is a polygon where everything's perfect. All the sides are the same length and all the angles are the same measure. So a lot of times in problems, it'll say, okay, you have a regular pentagon. That means all the sides are the same length, all the angles are the same, it's just perfect, perfect, perfect. So a regular polygon is perfect. They should just call it a perfect polygon because all sides are equal and all angles, this is my abbreviation for angles, by the way, are equal. And then irregular polygon, let's draw like maybe a hexagon, but it has 2 longer sides and like 4 shorter sides. all the sides aren't equal, and the angles aren't equal. So it's just irregular. Still a polygon, it still has straight sides, it's still closed, it's just irregular. Okay, the next two words that we need to know are convex polygon versus concave polygon. It has to do with it like folding in on itself or being able to draw a line that crosses through multiple parts. But the way I like to think of it is concave has a cave. And if you remember that, then you can easily differentiate it. If the shape has a cave, it's concave. If it doesn't have a cave, it's convex. So like looking at these two examples, this one has a cave, it would be concave. This one is going to be convex. That's how I remember it. And then over here, they made this nice little chart for you so you don't have to write it all out. We classify polygons by the number of sides. So a lot of these you've been working on since probably like kindergarten. A 3-sided shape is a triangle. Got it? And then 4-sided quadrilateral, 5-sided pentagon, 6-sided is a hexagon. 7-sided, this is one people forget a lot, is heptagon. And for whatever reason, the ones that people forget are the ones that show up on testing. So 7-sided is a heptagon, 8, a stop sign octagon, 9, nonagon, that's another one people forget, 10, decagon, and 12-sided is dodecagon. And then anything greater than that is an n-gon. What that means is like if you have a 14-sided shape, we call it a 14-gon. Or if you have like a 38-sided shape, it would just be a 38-gon. So if you see that in like a math problem, that's just a 38-sided shape. 30, yeah, sounded weird. Okay. Okay, then using that vocabulary, we're going to answer these. It says classify each polygon by the number of sides and then tell whether it's convex or concave. So here we're going to count the number of sides. 1, 2, 3, 4 sides. So this would be a quadrilateral. And then it has that cave, so concave. My handwriting is kind of bad there. Oops. Then the next one, counting the number of sides, 1, 2, 3, 4, 5, 6 sides. You can look at the chart if you need to. It is a hexagon. And it doesn't cave in, so this is convex. Okay, then down here, we're going to practice this. I want you to do it at the same time as me. It says classify the polygon by the number of sides, just like we just did, and then tell whether it's convex or concave. So answer these 3 questions. I'm going to freeze it here and answer it as well. And then we'll compare answers. So you're counting the number of sides, determining what it is. Okay. When you're done, just look up here and compare your answers. Okay. Any questions? Got it? Easy? Okay. Moving on to the next side. So this starts introducing perimeter and area on the coordinate plane. So just kind of a refresh. perimeter, I know you've seen this word before. Perimeter is just the distance around a shape. And then, oh, sorry, no, is it so crooked? And then area would be the space inside a shape. So for perimeter, you just add up all the side lengths, right? And then for area, there's usually an equation. They put some of the equations that we're going to use today for triangle, square, rectangle, and parallelogram right here. And then we'll use those on the other side. And then this right here is just an example problem, but we're going to practice it on the other side, like I said. So when you're ready, just flip to the next page and then we'll start the next page. Okay, so then on this page, this is where we're going to do some of the practice. The first four is what we just were practicing. It says classify the polygon by the number of sides and tell whether it's convex or concave. So we're just going to count the sides. So here we got 1, 2, 3, 4 sides. So that would be a quadrilateral. And it looks like it has a cave, so that would be concave. Number 2 looks like a triangle. 1, 2, 3 sides. That means it is a triangle. And it has no caves, so this would be convex. And then number 3, 1, 2, 3, 4, 5 sides. That would be a pentagon. No cave, so convex. And then for number 4, 1, 2, 3, 4, 5, 6 sides. So hexagon. It does have a cave, so this one is concave. So now we're going to get into this. Like I said, normally as part of the problem, you'd just be given the coordinates. You have to use your scratch paper to graph it all out. So getting to this point takes a couple minutes, but we already did that groundwork. So now that we have our shape, it asks us to find perimeter. So for all 4 of these, we're going to be finding perimeter, which is like the distance around the shape. So we need to find the length of each side and then add those up to find the perimeter. So for this first one, it's a rectangle. These lines are horizontal and vertical, so we can just count these coordinates. So we can go 1, 2, 3, 4. Okay, this is 4. And in a rectangle, like opposite sides are equal, so this is going to be 4 too. And then this side over here, 1, 2, 3, 4, 5, 6, 7 units. And then this would be 7 as well. Then to find perimeter, the distance around the shape, we add up those values. So 4 plus 7 plus 4 plus 7. So we equal 11 plus 11 is 22 units is the perimeter. Okay, number 6. Counting the units, 1, 2, 3, 4. This is 4, 4, and 4. It happens to be a square. You can count them all if you want. 2, 3, 4, cool. Okay, so perimeter, add up those values. We get 16. It's not unit squared or anything because with perimeter, it's just like length. So it's just a length. Okay, so for those, we could count all the lengths. This is more like an elementary or middle school level problem. These are more like high school level where maybe you can count some of the sides, but you do have to solve for at least one of the sides. So in this case for number 7, we can count the length of these two sides and then we'll have to solve for this one. So I'm going to count the length of this. 1, 2, 3, 4, 5. 2, 3, 8. And then to find this length, they gave me a right triangle, which is convenient because I can just use these dimensions to find this length. So like a squared plus b squared equals c squared. I'm just going to do 5 squared plus 8 squared equals c squared to find this length. So I get 25 plus 64, 89. Then take square root of both sides, and then c equals, it comes out to about 9.43, rounded to the hundredths place. And then that's that length right here, 9.43. Now that I have all the side lengths, now I can find perimeter just by adding up those values. 5 plus 8 plus 9.43, and this adds up to 22.43 units. Okay, the next one, I always look for something I can count first. So anything vertical or horizontal, I can just count. So it looks like this side right here, I can count the units. So I got 1, 2, 3, 4, 5. So I got that. But the other two sides are like on a diagonal, so I can't just count squares. I'm going to need to calculate it. So what I'm going to do is just sketch out a right triangle, and then I can use that right triangle to find that length. Like this is 2 units by 1, 2, 3, 4 units. So I get 2 squared plus 4 squared equals c squared. And I can solve for this length. And then c equals, square root of 20 comes out to 4.47. So this is 4.47. It's kind of squeezed in there, but yeah.
I don't understand the 4 and 2.
So that's what we did like yesterday and the day before, where we needed to find this length. We like sketched out a right triangle and used Pythagorean theorem to find that length. Like you could use distance formula, but I find this a little bit easier. I'm just sketching out a right triangle like this, and then I can use these dimensions in Pythagorean theorem to find this length.
Oh.
So this one too, it's on a diagonal. I can't just like count the squares. So I'm going to again sketch out a right triangle and use Pythagorean theorem to find that exact length. And then 3 units here and 1, 2, 3, 4 units there. And I get 3 squared plus 4 squared equals c squared. So I need to find this length. C equals 5. And then once you have each side length, you can add them. So 5 plus 5 plus 4.47 equals. This adds up to 14.47. Also, something I'll just mention that you'll probably use throughout the year. The 3, 4, 5 right triangle is a very common right triangle. So if you ever get a right triangle and the side lengths are 3 and 4, the hypotenuse is going to solve to 5. So that might save you some time calculating here and there. Okay, we're not going to do 9 or 10. We're going to go to the next page. We're going to go to number 11. Yes. Can you wait like 2 minutes? Okay. Okay, then over here, we're finding area now. Area. For area, as you know, there are equations for each type of shape. The shapes that we're dealing with here are triangles. It looks like a square and a parallelogram. The area of a triangle, this equation has to be memorized, or you might already have it memorized. Area of a triangle is 1/2 base times height. So for these two, we're using the equation 1/2 base times height. Area of a square is just length times width, or side times side. And then area of a parallelogram is base times height. And this one's on the reference sheet. Okay, so for this triangle, because it's a right triangle, like this is our base and this is our height. So the base here is 1, 2, 3, 4, 5 units, and it looks like the height is 3. So I'm just going to plug that into the equation. And then I will solve. 1/2 of 15, a lot of people ask how to put that in the calculator. Best way, I would say, is just 15 divided by 2. We'll give you the answer. It comes out to 12.5, and now we're dealing with area, so it's units squared. No, it's not. Sorry, 7.5. Thank you, good catch. Area equals 7.5 units squared. Sorry. Yes, not perfect. I'll just put that out there early. Okay, and then number 12. 12 is a triangle, same formula. This one is a little bit different. You get to choose what you want to use as your base. I'm always going to go for the easiest option. So this, I'm actually going to use as my base. So it's technically like upside down. So I'm going to use this as the base, and then the height has to be perpendicular from the base to the top. So I'm just drawing a height right here. And then the base length, I can just count those units. 1, 2, 3, 4, 5, 6, 7. And then the height here, I'm going to count this. 1, 2, 3, 4, 5, 6, 7. Area equals 1/2. Half of 49. So 49 divided by 2 would be 24.5 units squared. Last two are even easier than that. So for 13, it's a square. So you get 3 units here, 3 units here. So to find the area of the square, just 3 times 3, 9 units squared. And then for 14, for parallelogram, it's just base times height. For height, it's perpendicular height, so make sure that like you have a straight line, and that's 2 units for the height, and then the base is 1, 2, 3, 4, 5 units. So area equals 5 times 2. Area equals 10 units squared. Okay. So we're actually not going to do this part. We're in the kind of like an awkward amount of time, but because like by the time you get the laptops out, you would probably be almost like packing up. So because we're in that like awkward amount of time, I'm going to have you use your phones to get your homework started. Your to-do list is homework 1-4 on Schoology. You may have to finish it for homework because you might not be able to finish it in class. And then also working on Khan Academy as well. So at this point, you can get your phones. Please log on to Schoology onto the homework. I can see who's on it, and I'm going to bug you if you're not.